Let's jump right into this explainer. Today, we're breaking down the critical mechanics of securing your infrastructure using Terraform, S3, and Python. I mean, we all know how to build incredibly powerful cloud environments, right? But now we're going to explore how to actually protect the very blueprints that keep those environments running safely. Think about your last major deployment. The architecture itself was probably flawless, but the mechanism tracking it all, that might just be your biggest hidden liability. So let's get into it.
Here's our roadmap for today. We'll start with the Terraform infrastructure tool, then look at the dangers of Terraform state, how to lock that state with S3, automating the whole thing with Python, and finally wrap up with some secure infrastructure best practices.
Section 1, the Terraform infrastructure tool.
So, as you likely already know, Terraform is an absolute powerhouse for infrastructure as code. It lets us provision resources across AWS, Azure, or Google Cloud completely programmatically. But the true power of IAC isn't just in the building part. It's really in the tracking. To operate at any kind of scale, Terraform relies on a highly detailed blueprint so it knows exactly what exists in your cloud at any given microsecond. That blueprint, the state file, is your centralized source of truth. It maps your declarative code to real-world resources. But here's the catch. When we treat infrastructure entirely as code, the specific file tracking that state suddenly becomes the single most critical asset in our pipeline. And honestly, that is exactly where our security journey begins.
Which brings us to Section 2, Dangers of Terraform State. So what actually happens when two engineers update infrastructure at the exact same time? Picture this totally common scenario in a fast-paced DevOps environment. Engineer A pushes a critical patch to a security group to block a newly discovered vulnerability. But meanwhile, Engineer B is rushing to scale up an EC2 cluster to handle a massive spike in traffic. They both hit deploy. Because Terraform relies on that single state file to understand reality, those simultaneous commands create a massive, catastrophic collision. We aren't just talking about a harmless little error message here. Without safeguards, Terraform literally gets confused about the current state of the infrastructure versus the desired state. State corruption ensues. That means a simple typo or a split-second overlap can take down an entire production environment. Your infrastructure is just left in this broken, unpredictable limbo, and it's going to require hours of meticulous, manual untangling to fix.
The stakes here are just incredibly high. An unlocked state file is essentially an open vault sitting right in the middle of your organization. Not only are you vulnerable to those dangerous concurrent modifications we just talked about, but you're risking severe data integrity loss. And even worse, and this actually surprises a lot of engineers, Terraform state files often contain highly sensitive information. We're talking database passwords, private certificates, API keys, all stored entirely in plain text. Just think about that for a second. Your most tightly guarded secrets might just be sitting there, completely readable to anyone who can access that file. So shifting to a locked state isn't just some basic best practice. It is an absolutely mandatory mechanism to prevent concurrent overwrites and lock down your most critical operational secrets from unauthorized eyes.
All right, Section 3, Locking State with S3.
So how do we fix this? The standard cloud-native solution involves building a highly secure digital vault using an AWS S3 bucket. By utilizing the AWS SDK to implement an S3 bucket with object lock, you enforce a really strict write once, read many model during deployments. Basically, the file becomes temporarily immutable. When a Terraform run begins, it reaches out and claims a lock on a DynamoDB table or an S3 object. That signals to every other process that a deployment is underway, and until that run is completely finished, any other process or engineer attempting to make changes is blocked. They get a clear message that the state is currently locked. To pull this off, all you really have to do is update your Terraform configuration backend to point to this secured bucket. Do that, and you've instantly eradicated the risk of state collisions and unauthorized tampering.
Let's move on to Section 4, Automating with Python.
Now, manual security is kind of an oxymoron, right? If a human has to remember to lock the state before a deployment, trust me, it will eventually be forgotten. This is where we bridge the gap between intent and execution. Step 1 involves using Python's Boto3 library to interact directly and programmatically with S3. Boto3 is the AWS SDK for Python, and it lets you write scripts that manage your cloud resources natively. Step 2 utilizes the Terraform Python library to handle the actual infrastructure commands, effectively wrapping the Terraform CLI. And in Step 3, you weave these tools together right inside your CI/CD pipeline. Your Python script automatically triggers Boto3 to ensure the S3 bucket is locked, runs the Terraform plan and applies safely, and then reliably unlocks it as soon as it's done. It's a completely automated, foolproof workflow that entirely removes the risk of human error from your deployment cycles. It's a real game changer.
Section 5. Secure Infrastructure Best Practices.
Zooming out a bit, securing your infrastructure definitely doesn't stop at S3 locking. That's really just securing the front door. You also need to ensure the windows are shut, which requires a much more holistic approach. Mandatory version control for all your Terraform configurations ensures you have an immutable, auditable history of every change ever proposed. If something breaks, you know exactly who changed what and exactly when they did it. On top of that, implementing comprehensive monitoring and logging allows you to detect unusual activity the exact moment it happens. By tracking API calls to your state file bucket, you can instantly flag unauthorized access attempts. When you combine this with state locking, these practices ensure you maintain the rigorous security and compliance standards required in modern, enterprise-scale cloud environments.
Managing infrastructure through code grants us incredible power and scale. I mean, it allows teams to build complex architectures in literally minutes. But true operational maturity comes from ensuring the absolute integrity of the tools managing that power. State file vulnerabilities are very real, and leaving them unaddressed is basically a ticking time bomb. S3 locking and Python automation are vital, proactive steps in that maturity journey. I want to leave you with this final thought to consider about your own deployment pipelines and the hidden risks that might be lingering right now. If your infrastructure is entirely defined by code, how secure are the tools guarding the keys to that code?